Hi, my name is Miguel Angel Lirra from Mexico City, Mexico. This lesson covers week 2 of the Coursera course Introduction to Music Production. I have chosen to present the analog to digital conversion process. I hope you find it interesting. Information from analog into digital form and back again without losing details. Although the electronic circuits to do this can be quite complex, the basic idea is fairly simple. To see how it works, we can consider turning the analog waveform into a string of binary numbers. The form shown right now represents the kind of analog pattern generated by telephones. These waves are converted into digital patterns for transmission by taking a series of samples. Each sample represents the wave's voltage level at a specific moment. Let's focus here on just one sample, the one represented by the orange blob. Step in sampling the waveform is to choose a signal range, a range of voltage levels large enough to cover all the variations up and down that the signal makes. The next step is to divide the range into equal halves. In the diagram, this cut is shown by the red line. We then ask, is the point we're sampling above this line? If it is above the line, we note down a 1 is below, we note down a 0. We now divide the half range which the sample occupies in two equal halves. Since in this case it is the top half, this division is at the yellow line. Once again, we ask, is the sample above the line? If above, we tack 1 onto our previous answer. If below, we tack on a 0. In this case, the sample we're looking at, the orange blob, is above the first red line and below the second yellow line. So we collect the result 1, 0 or 10 from our first two uses of this divide and question method. We can repeat this process as many times as we like, each time gaining another bit of information about the point whose level we are trying to determine. In the example, we have done this a third time, the blue line. As a result, we can say that the level is in the band of voltages we can represent by the number 101, 101. The more times we divide the range and answer the question about which side of the line the sample lies on, and the more bits of information we get. As the number of bits increases, so we know the precise level more accurately. In practice, we can stop asking after a while because we will reach a level when random noise blurs the signal, making a further bits meaningless. By taking a series of samples, each time using this yes-no process, we can convert all the details of the analog waveform into a stream of binary numbers. For example, the above wave can be represented by the series 110, 110, 111, 111, 101, 100, 011, etc. By taking 3 bits per sample for the sampled points indicated by the circles, in fact, we can see that we should have taken more bits per sample and used more samples to convert all the details of this particular wave. This would increase the number of bits we would get. But the argument is just the same as above. Thank you for watching.